Dipankar Raychaudhuri. Dipankar Raychaudhuri, a.k.a, born January 16, 1955, is the Director of Wireless Information Network Laboratory WINLAB and Distinguished Professor in the Electrical and Computer Engineering Department at Rutgers University. Education. Raychaudhuri obtained his B.Tech Hons in Electronics and Electrical Communications Engineering from the Indian Institute of Technology, Kharagpur in 1976, and the MS and Ph.D. degrees from Stony Brook University in 1978 and 1979, respectively. His Ph.D. was in the topic of code division multiple access CDMA under the guidance of the late Professor Stephen Rappaport, who continued to be a mentor and close associate after graduation from sunny Stony Brook. Career. As a distinguished professor in electrical and computer engineering and director of the WINLAB Wireless Information Network Lab at Rutgers University, Raychaudhuri is responsible for an internationally recognized industry university research center specializing in wireless technology. He is also principal investigator for several large National Science Foundation-funded projects, including the Orbit Wireless Testbed, the Mobility First Future Internet Architecture, and the Cosmos Platforms for Advanced Wireless Research Power program. Dr. Raychaudhuri has previously held corporate R&D positions including Chief Scientist, iSpan Wireless 2000-1, Assistant General Manager and Department Head, NEC Laboratories 1993-99 and Head, Broadband Communications, Zarnov Corporation 1990-92. He obtained the B.Tech Hons from IIT Kharagpur in 1976 and the MS and Ph.D. degrees from Stony Brook University in 1978-79. He is a Fellow of the IEE and the recipient of several professional awards, including the Rutgers School of Engineering Faculty of the Year Award 2017, IEE Donald J. Fink Award 2014, Indian Institute of Technology, Kharagpur, Distinguished Alumni Award 2012, and the Schwarzkopf Prize for Technological Innovation 2008. Dr. Raychaudhuri is a leading researcher/technologist in the field of wireless networking based on his sustained technology contributions and leadership over the past 38 years. He is acknowledged as a pioneer who helped bring broadband wireless access technology from concept to reality in the 1990s. This is a technology domain high-speed WLAN, WiMAX, etc., which has made it possible for hundreds of millions of people connect to the Internet. Prof. Raychaudhuri is also recognized today in the U.S. academic research community as a forward-looking network architect who is leading National Science Foundation-supported R&D initiatives to innovate the future mobile Internet from a clean slate perspective (FIA) and to develop open, programmable wireless and network testbeds Orbit, Genie, and Cosmos. Finally, as director of WINLAB since 2001, he has led development of an internationally acclaimed academic research center specializing in wireless technology, and in this capacity plays a visible leadership role in advancing basic research and education in the field. Dr. Raychaudhuri has also been active in technology entrepreneurship, helping to incubate startup companies in the wireless networking and media areas over the past 18 years. He serves as technical advisor or board member to several new technology companies, and has previously served on the advisory council of the Indian Economic Development Authority's Edison Innovation Fund. He has also served as editor of several leading journals including IEE Transactions on Communications, IEE/ACM Transactions on Networking, and IEE Communications Magazine. He has participated in several international standards committees in the telecom field, and has been an external advisor for several European and Japanese research projects, and is currently a member of the International Advisory Council of the NICT. Notable achievements. Notable technology innovations by Professor Raychaudhuri include design and implementation of one of the world's first broadband wireless local area networks. He published his concept for an ATM-based broadband wireless access network in a landmark paper in IEEJ, Selected Areas in Communications, 1992. This paper went on to become the second most highly cited journal paper in the communications field between 1990 and 2005, according to ISI Thomson Reuters. Dr. Raychaudhuri's research group at NEC C&C Laboratories in Princeton subsequently demonstrated the feasibility of reliable 25 Mbps mobile services in the 5 GHz band, and successfully conducted proof-of-concept field trials as early as 1998. Other important research results in his career include design and prototyping one of the earliest VSAT very small aperture terminal data networks during the 1980s. This technology enabled the first generation of data networks in the US and is still used to provide internet access to remote areas all over the world. In the early 1990s, he was the co-lead for a multi-company research team which designed one of the first HDTV systems tested by the FCC in 1991. Significantly influencing the a.k.a. digital TV standard in wide use today. After joining Rutgers as a professor, Dr. Raychaudhuri collaborated with Ivan Saskar, chief technologist at WINLAB, to build the Orbit Radio Grid testbed, the world's largest open research testbed for evaluation of future wireless networking protocols. During the period 2010-18, his group at WINLAB has also developed a novel clean slate mobility-centric future internet architecture called Mobility First, which proposes a new named object approach to internet routing based on the use of globally unique identifiers GIDs in place of conventional IP addresses. More recently, his research group at WINLAB has been leading a major NSF project funded under the Platforms for Advanced Wireless Power program aimed at deploying the city-scale open/programmable Cosmos testbed in New York City for research on next-generation wireless networks with edge cloud capabilities. Gallery. The wireless ATM network supports the delivery of multimedia information to portable computing devices of the future. Dipankar Raychaudhuri, Bob Syracuse, Cesar Johnston, Subir Biswas, and Max Ott demonstrates CCRL's W18 prototype. The NEC laptop computer in the foreground serves as a personal information appliance BIA which retrieves multimedia streams such as MPEG video over the microcellular wireless ATM network. The prototype system is capable of supporting standard ATM services at the portable terminal, with quality of service coerce control and handoff of active connections from one macrocell base station to another. The CCRL team has made seminal contributions to the field of wireless ATM, and has played a key role in forming a working group on this subject within the ATM forum. The text from NEC CCRL brochure. Book. Emerging Wireless Technologies and the Future Mobile Internet, Cambridge University Press. Awards. ISI most frequently cited author in the field of communications during 1985 and 2005-2006 Fellow of i.e. 1995 Schwarzkopf Prize for Technological Innovation 2008 i.e. Donald G. Fink Prize Paper Award 2014 Faculty of the Year Award at Rutgers School of Engineering 2017.